Good morning, all of you. Let us have a look at this JEE advanced question from 2008. This was a comprehension based question, and the concept involved is from rotational mechanics. So let us first analyze this question. So he has given that there is a uniform thin cylindrical disc of mass capital M and radius capital R. So this is a cylindrical disc of mass M and radius capital R. See, I have drawn it like a wheel here, okay, so that it is very easy for you to visualize rotation motion. So just remember that it is a cylindrical disc. That is what is given in the question. This mass M is attached to two identical massless springs of spring constant K. Right? So this mass here is attached to two springs which are of spring constant K. These springs are fixed to the wall as shown in the figure. So you can see these two springs here, they are fixed to the wall. Next, the springs are attached to the axle of the disc symmetrically on either side at a distance d from the center. So these two springs are fixed symmetrically to this cylinder with the help of an axle. You see this? And the distance of this axle from the spring to the disc is d. So this is d here, and from here to here it is d. So the spacing between the two springs here is 2d. Next, the axle is massless and both the springs and the axle are in horizontal plane. So this axle that you see here, it is massless, and the spring, axle and spring, all these are in the horizontal plane. Next, the unstretched length of each spring is L. Right, so the unstretched length of the spring and the spring both is L. The disc is initially at equilibrium position with its center of mass at a distance L from the wall. So initially this disc here is in equilibrium and its center of mass is at a distance of capital L from the wall. Next, the disc starts rolling without slipping with a velocity v0 I cap. So he has given I cap here. So this disc starts rolling along the positive x direction. Okay. Next, the coefficient of friction is mu. So he's saying the coefficient of friction between this disc and the floor is mu. Okay. He's asking the net external force acting on the disc when its center of mass is at a displacement x with respect to its equilibrium position. So when this disc is at a distance x from the equilibrium position, what is the net external force acting on the disc? So we need to give our answer in terms of k and x. So you can see here at its equilibrium position, it had a velocity v0 and it is oscillating to and fro. And one more thing that you can observe here is that this disc is not slipping and it is pure rolling. So we need to find the net force on this disc when it is at a distance x from its equilibrium position. Let us first draw the free body diagram of the disc. So this is a disc here, and let us draw the free body diagram. I am considering only the forces along x-axis, which is in the horizontal direction. So firstly, as there are two springs, these two springs are compressed by x. So they exert a force along the positive x direction. I'm representing this here. So the two springs are exerting a force in this direction, which is 2kx. Next, I'm marking the friction here towards left. You can choose the friction in any direction. When you write the no slip condition correctly, you will finally get the correct answer. Next, I'm marking the acceleration in this direction and the angular acceleration in this direction. Now along this direction we can write net force equals to mass into acceleration. So along the x-axis net force is 2kx minus friction force. So 2kx minus friction force equals to total mass into the acceleration. Next, the torque about the center O. So the torque about O due to this force F is F into R. So that is F into R. The torque due to 2kx is 0 because it passes through this point. So F into R equals to I, moment of inertia of the cylinder about its center is mr square by 2 into alpha. So torque equals to I about O into alpha. Next, let us write the no slip condition at O dash. So we know that when there is no slipping, the tangential acceleration of this point is 0. So we can write A minus R alpha equals to 0. In the first question, he is asking for the net force on this disc. So if we can find what is m into a, or if we can find what is acceleration, this ma will be the net force on the disc. Okay, so our job right now would be to find what is the acceleration. So now we'll just simplify the equations to find the answer. First we are putting equation 3 into, so we have taken this as equation 1, this as equation 2, and this as equation 3. We are putting 3 in 2, which means we are putting the value of alpha from equation 3 in equation 2. So F into R equals to mr square by 2 into alpha we are writing as A divided by R. So alpha we are writing as A divided by R. R here gets cancelled and another R and R here gets cancelled. So we get F equals to ma by 2. Let us keep this as equation 4. Next, putting equation 4 in 1, which means we are substituting this in equation 1. We get 2kx, which is 2kx minus friction F here is ma by 2. From here we are keeping this ma by 2 equals to mass into acceleration. So if we simplify this, we get 2kx equals to 3 ma by 2, or ma, which is the net force acting on the disc, equals to 4kx by 3. In the exam he had given the option as minus 4kx by 3. The reason being the positive x-axis was in this direction and x was to the left. The displacement of this cylinder here is to the left. When it is to the left, the net force is towards the right. So that is why we have got here as minus 4kx by 3. There were 2 more questions in this comprehension. I'll be discussing those both questions in the coming parts.